opportunity, and I would like to say hello to all the listeners here. And this is a very pertinent crop topic, that the crop regulation is very important for the farmer's point of view. One, to reduce the growing period of the crop, also to take the uniform cropping, uniform produce at a time, and to market it at a time for higher price, and also to reduce the time frame of the crop so that an additional crop can be grown in the protected cultivation. So this is very important to have to manipulate light for crop growth. So as you see, light plays an important role besides the temperature. So if you see the radiance of the light over the day and over the months and during the year, that changes from short day to long day in any given condition. If the protected cultivation is being followed, then both the thermo as well as photosensitivity of the climate factors are very important to go for the simulation of growth for crop regulation. So here I would like to give you the effect in general, that the color filtration is very important to the crop, and this color is why the white color has all the wavelengths and the radiation in it, and it is very much sure that the red color radiation will have more of UVs and the blue color radiation will have the least of UVs. So if we say that at the same time the color is very important for the plants to be absorbed. As you see the spectra of color in the range of normal light, it is distributed from the morning to evening and also end of the day and the rise of the sun. And in this slide, it shows a real significance of the light, the photoperiod. If there is a light on in the night, so it means the day length is longer. So the plants which are adapted for short day length can flower only when the days are short. Means the nights are longer, the days are short. So if you have the day length longer than the night, it means the photosensitive plants will not flower at all. And where there is enough dark or enough dark effect on the plants, because this light is interrupting the plants to go into the dark period during night, so they will not flower. So chrysanthemum is an example where the sensitivity of photoperiod is very intense. So normally we say chrysanthemum is a short day plant, but it's a long night plant. So if the nights are longer, they will flower early. So here the critical day length is very important, whether a crop is grown in the greenhouse. So the downside photograph you see, if you provide all the way the long day length, the chrysanthemum, irrespective of the good growth and the plant height, will not flower at all. But in case if you don't provide any long day length, and irrespective of the minimum number of days of longer photoperiod required are perceived by the crops, they will flower. So it does not mean, but the flowering would be ununiform. So at the same time, the uniform growth is required for regulation of the produce to the market, and also the flowering which Say for example, if you do not have any uniform flowering, so hardly 10 to 15% produce will be harvested at a time, and you can bring take the less number of stems to the market. So, and then again some flowers will come again. So this harvesting period will be very much disturbed. So this is why we need the crop regulation in terms of photoperiodic and also in terms of photothermal. So here it is very important to note that the very first precaution, the chrysanthemum does not have any seed. They are not grown by seeds. They are grown by the stem cuttings. So having grown mother stalk in the longer day length are ideal to take the terminal cuttings for new plants. So this is very important to note that the plants grown in the different days would be affecting the root growth and also the uniformity of the crop. So if we plant these different batches, the plants, baby plants or small plants or seedlings made from these mother plants would give flowering at different times. So if you go to the research studies conducted over the period of time, in any plants, any seasonal flower, we call them seasonal because they are affected by seasons and they can be grown in particular season. And chrysanthemum is the flower which comes with the first in the season. So the flowering is very early in the season as compared to the other seasonal flowering plants. So chrysanthemum is a typical example. So if we give a different exposure of day lengths to different batches and as mother stock, and we prepare new plants from them. So because this new sap is flowing in the mother stock. So the research studies have shown that if there is a new sap flowing in the mother plants and baby plants are prepared from them, so they will have a very good growth and good flower. So this is one aspect. The another aspect is the number of exposure days to long days will decide how much time they will take to flower. So this theory that they do have a reaction time genetically governed according to the varieties and their types sometimes does not work because it requires minimum number of days of long day length to come to complete the vegetative growth, and then they will turn into the reproductive phase. So this is also very important to note that the different plants, if they are grown, they will have this, a sap flow differences because the number of roots or the volume of roots will decide the sap amount of sap and the quality of sap flow in the plants, which will decide the growth of new plants and also the flowering. So if we have several times experimented beyond the season and after the season that the self-rooted cuttings, they may or may not be affected by if we prepare in the season when the short day length is there. So you will see the immediately after the self-rooted cuttings have established, you will see the buds are apparent on the top. It means the plants were not exposed yet for the longer days, so they are having a tendency to break into the bud. But in case of the period when the longer day lengths are required, so the light is limiting factor. So here in the different photographs, you will see how much light is enough to regulate a crop. So in case of any plants, so the minimum light is required to give a vegetative growth signal. So as you see, the signal of the growth is perceived in the leaves and it is transmitted to the apex. So the quantum energy received from the light for the growth is not exactly what you have given. So this can vary from 110 micromole to 160 micromole. But for chrysanthemum, as I said, they are sod plants. But if a small illumination of light can be given to the plants, they have the same effect. So their tendency to give a signal from the leaf which travels to the apex is somehow restricted when we again expose them to the light. So that's why the continuous lighting is more important than the continuous light. So even after the break, like half an hour in 2 hours, if we give 1.5 hours stop and 1.5 hour on the lights, so they will have the same effect, because the signal is perceived from the leaf and that will travel to the apex to generate them reproductive. So as soon as the light cycle goes on, so we have seen that from 90 micromole, this effect is perceived in the plants and they are no more become reproductive. And if we say 135 micromole and 125 micromole and 131 micromole. So 131 micromole light is enough. It is why it is important. It is important because a farmer has to spend a lot of money making the lights on in the night, because if you have a 100-watt bulb in 1 acre area, so normally the number of bulbs would be around somewhere 280 bulbs would be required. So you can calculate the consumption of light. So farmer has to pay the heavy bill. No matter this light would be on only for 2 to 3 weeks time, which is enough for the plants to grow vegetatively, sufficient for having sufficient stem length to the required by the market. So, but in the additional expenses on lighting would cost a very high amount. So cyclic light is important, because if we are giving 4 hours additional light, so then we will need only 3 times half an hour each. So out of 4 hours, hardly 1 to 1.5 hour lighting would be on. So we can save 50% or more than 50% on the expenses from the electricity bills. So this is very important to note, that how much light is sufficient. So if we need not to give more light, so we can have the minimum expenditure on crop growth. So this is very important. So now you see, if the lights are on, they will have uniform growth. So after uniform growth, what is happening? Again, you can see here, after giving so much light, if the plants are growing indoors, so they have so many factors: temperature, low temperature, and also high humidity, very high humidity. This variation between low and high ranges of temperature and the humidity will affect the efficiency of light in the greenhouse. So similarly, if you see the variation between lowest and the highest is maximum, so your crop growth is affected too much. So there is a maximum impact on the growth, negative impact on the growth, if the ranges are too very high. So smallest are the differences between the high and the maximum values. So you will have a uniform crop growth, and you can see here, after having the uniform crop growth, you will have a uniform flowering. So all the flower heads would be harvested at one time, and you will have a very good crop for the market. So this study is very useful, that how much light can be given and what should be the temperature. So during the low temperature months, you need to curtain down all the structures so that the minimum variation between the day and night temperature can be maintained. Similarly, the availability of light, if suppose the light were too high in the day and too less in the day, to supplement that light, we need lighting in the night also. So though this night light is hardly 4 to 6 hours, if you have the winter days, then for 6 hours, And if you have the summer days to break into the flowering, you need only 4 hours lighting. If you have the arrangement of cyclic light, then you can have only 3 times on and off lighting pattern, half an hour on and 1.5 hour off. So this would create a similar effect on the crop growth. This is very much important. And also, this process is followed, the lighting process is followed soon after the pinching in spray types. So this is a hard pinch. So you allow 2 to 3 stems to grow up after pinching, and immediately the lights are on. So since the lights are on and you get almost 25 to 30 centimeter height, then these lights can be stopped. So after this, your plants would be reaching to 60-65 centimeter before the bud comes. So very soon, it takes 3 to 4 weeks to come to arise the buds. And then if this is spray type, you can pinch the apex bud so that the lateral branches, it can come uniform and have the flowering at one height. And if the standard one is your variety in the greenhouse, then you can disbud the lateral branches and also disbud the buds below the apex. So this is one flower which we have to take from the standard varieties, and uniform but a small flower, many flowers in the spray type. So this is very important to note that the variety and the types, their practice would be followed after the light for 2 to 3 weeks, or at the maximum around 21 to 24 days you have followed. So this is a very peculiar pattern of growth, where in the greenhouse you can manage a crop like for 60 to 65 days time. And if you want more stem length, then it can be maintained until 85 to 90 days for harvesting. So this is very important to note that the varieties, because they're genetically different, and also the cultural practices are they can make them delay for 12 to 15 days time in the harvesting as compared to the spray types, the standard one. So this is one more experiment conducted on the lighting to restrict the lighting and also to give the direct. So the experiment were undertaken very on large scale, that if what can we do if we need with the lighting, too much of lighting, because lighting given more than 30 days in longer days. So this will create a crop which will flower, but enormously, maybe 2 meter longer stems. And also on the other hand, if the flowering is coincide with the higher temperature, then these buds may degenerate, means the flower abortion will take place. It happens in the varieties which are temperature sensitive. So now the breeding of chrysanthemum varieties has taken place, where they are temperature insensitive, but they are sensitive to light. The very simple phenomenon is that the light is a very important part to regulate the crop, but the temperature can be sustained. But if you say the garden varieties of chrysanthemum, they are very natural. If you grow them under the longer days, at high temperature, then the flowering will be aborted and you will not have any uniform crop growth. So that's why here in one explanation is before you, that the varieties for the chrysanthemum or any flower crops for greenhouse conditions are different, and for open field conditions are different. So kindly note that the greenhouse varieties are different, and now they are available in the market. So you have to choose the varieties which are um, auto flowering, like they need not to pinch, they need not to stake, so they will be growing according to your requirement. But if you grow the garden varieties inside the greenhouse, they may or may not be uniform in growth, and you may have to wait for many months because they are adapted to the different level of light and temperature variations. So they will not be performing very uniform in the greenhouse structures. So here, I would like to endorse that the varieties which have been collected over the time, so hardly out of almost 1,000 number of varieties, we could get only 5 to 6 varieties which can perform consistently under the normal conditions. So here, as I said, what are the normal conditions? Normal conditions are when we provide enough wavelength of light in the range of blue and red zone. So as you see, the spectrum is such that the blue being 80% and red being 20%. If you see the 20%, 80% blue will produce exceptionally longer stems. And if you have 80% red, 20% blue, then they will excessively produce dwarf stems. So the light regulation is very important to increase or decrease the spectra in terms of blue and red. So the other rest of the other colors, the plant does not recognize, and then they does not give any photosynthesis acclimation in the leaves to assimilate the maximum photosynthesis for growth. So this is very important to note here, that the portion of blue is higher than the elongation is maximum. The portion of red is higher, then the dwarfing effect is maximum. So if we want to regulate the stem length, so we have to decrease or increase the quantum of red light exposure to the plants. And also, if we want stem length more, then we have to increase the blue portion of light in the illumination. So as you see here, over the period that the same batch was exposed to the short day and then short day plus additional blue and long day with the PAR radiation. So, but it is exceptionally longer days, means 15 hours day length. And this is only blue, but it is a 15-hour day length. So here you can see, if we increase the number, but with blue, we will have the weaker stems, but the flowering would be ideal. If we have additional blue, but if we increase, if we have the same day length, then our stems would be stronger. If we do not have any longer period, but with short days, then we'll have the dwarf plant, because only the red light is given here. So the plants would be dwarf. And if we give only exceptionally longer days, so you can see here, stem length would be very, stem would be very thick and length would be the longest, but the flower quality would be affected. So here there is a management of light, which is which you need to look for, this one. And here the development of bud, as I said, if you have the longer days, then there are more chances to abort, to get the buds abort. So that's why you do not have uniform flowering, and also good flowering is not available. So if you have the normal pattern of exposure to combination of blue and red, the blue being 80% and red being 80% and blue being 20%, is an ideal combination for the exposure. So here there is a possibility that we can still have the bud formation and flowering completely in 61 days time. So this is a crop, if we manipulate the lighting condition, so we can get a crop within 60 days time. So if we say we provide for a short, no longer days, but sufficient exposure of light, and you can see if the longer days are given for 0, so still we have, but the stem length is very short. So you can see the stem length is increased by the number of days with long day. So this is very important to note. Irrespective of the varieties, standard and spray types, we will have the similar effect if we are providing the photoperiodic light. So this experiment shows that even in the 4 square inch pots, you can have a normal crop within 60 to 65 days ready for harvesting. And irrespective of the varieties, spray types and standard type, because you are manipulating the day length here. And as soon as the growth is achieved like 30 to 40 centimeter, you stop the light and make the long nights. So long nights means short days. So if your night is longer, you can make short days and then the flower can come uniformly. This is very important. Now, as I spoke, the varieties are available in the market, which are no pinch, no stake varieties. So you have planted the varieties, and you can see here all over the lighting is there, which is now photosynthetic lighting. And the chrysanthemum varieties, they are now in the market, so you can completely harvest in the greenhouse itself and stick for the direct marketing. So this is very important to note, that the a batch is so regulated that at a time your greenhouse is empty after harvesting, and you can harvest uniform crops after 60 to 75 days time, which is a very uniform crop, and you can uh, uh, no longer wait to send it to the market. Even the processing is very easy. You can process it at the site itself, in the greenhouse itself. So this is a kind of revolution that we now have, the thermo-insensitive but photo-insensitive varieties, where we can regulate the lighting and we can regulate the 4 to 5 crops in 1 year. So this is very simple. And also this application of photoperiodic manipulation is going to roses also, and vegetable crops also, where 35% more economic yield is reported. And very soon this technology would be very less costly, also for vegetables, also for pot flowering plants like anthurium, and so many seasonal flowers. Although the seasonal flowers take very less time, but you can have a possibility of growing 6 to 7 batches in the controlled conditions, where you can manipulate the light and the temperature very effectively. Of course, the benches, where the benches can be cleaned very easily, and your batches can be out for the market. So these the climate maintenance part is also going to be very simpler. And how to harvest the energy and the heat. So the energy from the ground in terms of hot air can be flown in the greenhouse, and the solar lights can be equipped, which they will harvest the solar lights, and during the night the greenhouse would be illuminated, and your rose crop and the other flower crops would be very happy in the times to come. So again, the design is also going to come for a good greenhouses, where the roofs is fitted with the solar panels, where the energy and the light requirement would be met in the conditions or in the climate where hardly a few hours sunlight is available. So the natural light manipulation is very important, because to reduce the expenditure on the crop cultivation. Similarly, the roof will harvest the light, and there will be multi-layer farming in the future times to come, and the greenhouse industry would harvest the more quality and the more productivity out of greenhouses. And the similar, like the greenhouses which are 100% transparent, and no matter the angle of the sun is going where, so all the light energy would be trapped inside in the day and can be conserved in the night time, and it would be like fashion industry in the times to come. And similar, the roof would be designed so that they will, all the angles, they will harvest lights, and it will go to the crops, and the crops will be manipulated irrespective of the flowers and vegetable crops. And also the retractable roof has been introduced, where the multi-layer roofing is there. So the light, whatever light amount of light in the areas where there is arid climate, hot climate, and the warm climate is available, and the light levels are so high the crop can be burned. So multi-layer retractable roof greenhouses are coming in the future, where if you want to have more light, you can open number of layers. If you want to have less light, you can close some of the layers and open a few of the layers of the greenhouse roofs. And this would be very easy in the times to come to regulate the flower and flower crops in the perennial crop industry. So, and also for the potted flowering plants. So this is the time has to come where almost all the climates would govern the eco-friendly and environment-friendly structures, where the cost of cultivation would be reduced and the cropping quality would be enhanced. And at the same time, you will have a fun to even walk on the greenhouse roofs. They would be very sturdy and very strong. So thank you very much. If you have any questions, any doubts, any clarifications, you're most welcome to ask. Thank you so much.
Thank you very much, sir. Thank you for a wonderful presentation. I'll take up the questions from the participants now. Can you please stop sharing the screen, sir, so that we can see your full video. Top, you yeah. Thank you very much, sir. First question is, how do you measure a photo period?
Yeah, now it's very simple. The light sensors are coming in the market. So light sensors are available. So you can measure anywhere, anytime, and you can regulate the requirement of light.
Okay. What is the critical period for photoperiodic plants?
Yeah, if we divide the day into 12 plus 12 hours, light and dark. So, and we should not be confused, because the plants, they do not do any photosynthesis somewhere around 11 to 3 p.m. So if you take out this part, so in the early morning, after the sun rises and also end of the day, light is very important. So we get critical light 7 to 8 hours. If we think that quantum of light is around 530 micromole, then the plants are still photosynthetically functional. If this light is going high, then plants are not doing any more photosynthesis, because all the plants, they avoid photodamage. They want to avoid photodamage, and they shut down the stomachs, and there is no more photosynthesis. So the only evening and morning part is very important. So therefore, the critical day length is, like for short day plants, it's 7 to 9 hours. And for the long day plants, it's 13 to 15 hours.
Okay. How long does a photo period take to grow?
Yeah, it depends on your objective, how much length you need. If you are growing spray type chrysanthemum, then you need only 60 to 65 centimeter stem length. If you are growing standards, then you need 80 to 80 centimeter to 1 meter stem length. So it depends on your choice. So if we say for spray types, 11 to 13 days illumination is enough, but for standard types, we need to go up to 21 days for having 1 meter long stems.
Okay. How long does it take a chrysanthemum to flower?
It depends on the types, as I said. So spray types normally can flower early. Standard types can flower little late. But if you want spray types to flower along with the standard types, because you want to take two of the varieties at the same time to the market. So normally the spray types, you have to give little longer photo. So like I said, if you will give 21 days also to spray types, they will not flower early.
Okay. The next question is, for commercial cultivation of chrysanthemum, which is the best place you recommend for buying planting material?
Yeah, if you see for chrysanthemum, if you see in West Bengal, so normally on equator like Pune, Nasik, Bangalore, equatorial region is the same day length. And these areas, they produce longer day chrysanthemum, and they are good for manipulating light to have rooted cuttings. So best rooting cuttings can be made in the areas like Pune, Nasik, Bangalore, and so Calcutta. So these are the very good areas for making chrysanthemum plants for business.
Okay. Do you provide any consultancy for chrysanthemum cultivation?
Yes, ma'am. We and our institute is open for the MOUs with the companies or with the farmers, and also for farmers we are freely available at any time. They can contact us and take the guidance.
Okay. We have one last question, sir. Please tell us about your background. How come you got interested in this field?
Yes, I am a scientist, and I studied my master's and PhD in horticulture, floriculture, and I could get my postdoctorate from Netherlands on food supply chain, where I worked on chrysanthemum extensively with photoperiodic crop regulation. So, and since then I am working for last 24 years with the chrysanthemum and other flower crops.
Okay, thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Dr. Mam Singh for the talk and for answering the questions. I like to also thank all the participants in the meeting. This meeting will now be closed.
You're welcome, ma'am. Thank you so much. Thank you.
You're welcome, sir.
And thank you all the listeners who have listened patiently.
Thank you, sir.